gentlemen, I'm Jon.
I'm Whitney.
And we're here to talk to you today about the handheld penetrometer.
Wah, wah, wah.
No, that's not what we're doing a CCRL part 2.
Even more. Wah, wah, wah.
Talk. We just got done preparing the sand. Bum, bum, bum! And, you know, you saw some of the boxes, and Patchoula's going to throw an overlay here. And is that what it's called? And the video that shows us prepping the sand, right. And please forgive us if we're moving a little slow. We have 4 kids, and we run around a lot. So we did the aggregate prep, right. And in the aggregate prep, what we wanted to go over was 3 things. What CCRL tells you to do.
What the C192 tells you to do.
ASTM.
Right.
And then why you should give a shit.
How they're different.
And
then
why you should give a shit. And why it's the why it matters. Like, why are you listening to this video? So let's dive into it. What does our CCRL tell us to do, love?
To dry it. Do oven dry.
And then cooled.
So bring it back to ambient. Here's the thing, though, too, that surprised me.
105 to 115 degrees Celsius. Sorry to interrupt.
You're fine.
Sorry.
I mean, you make it really hot to dry it out, which was surprising. But my bigger, when we were just going through the instructions, right. Was that they're assuming...
Oh, yeah.
No absorption.
No absorption.
It was zero absorption.
So they are assuming an absorption, but they're assuming the absorption of the aggregate. For those of you who don't know what we're talking about, when we say absorption of aggregate, we're talking about the amount of absorption compared to the aggregate's own weight that the aggregate will absorb into itself.
So the pulling water from the mix.
Right. We're just pulling water from the environment, pulling moisture.
Sure.
So the CCRL tells us to oven dry at 105 to 115 Celsius or 210 to 220-ish, something like that. I'm math quickly in head. 1.8 times 100 is 180 plus 32.2.
212?
Is 212, but it's 105.
Right.
So then really, 5 times 1.8 is 9. Right. So it's hot. 250, something like that.
Like you're melting crayons.
I was just trying to do that math. It wasn't working in my head. So what we want to make sure is that we're following the CCRL.
Right.
But when you look at the 192, this is that. Is dichotomy the right word? I'm not sure. This is the rub.
Right.
The 192, if you look at ASTMC, or this ASTM says...
saturated condition.
And I thought it said up to 24 hours. I know it was.
Yeah, something about 24 hours.
It's in section
7.3.2.3.
Oh, I was going to say it incorrectly. I'm glad you... Dichotomy between the two.
Right.
So again, the CCRL says oven dry and then cool. And then the 192 tells us to saturate it, SSD. Right. So get it wet to the point where it's saturated surface at 24 hours prior to use.
Right. Yeah, draining. Preclude loss by draining at least 24 hours.
So, are we being picky? Why are we being picky? Yes, of course, we're being picky. I'm high maintenance. I'm okay with that, right, Whit? In all things, I'm high maintenance. So, why should we care about this then, Whit? Why do we give a shit about dry versus...
I think that the frustrating thing, in a lab, we try to mimic what actually happens in the field and in the industry as much as possible. Right. And if we're doing an oven dry, and I can appreciate and understand to a point why they're doing it, right? They're trying to get everybody, like the Scantrons, right? Why do we do tests with the Scantrons?
Don't start me on that.
Well, no, but they're easier to grade, right? You're trying to do a baseline, and everyone submits the same answers, how they got it, whatever, but it's just...
my turn.
Right. So that's kind of, why I think it's...
Yeah. They execute that. They deploy that.
Right.
The problem that I see is that, first of all, to go against, not that I would argue with my boss and my lovely wife, but we already have protocol in place to deal with that.
Sure.
You have getting the moisture on sand and rock. And why should they assume a 0% on the absorption when we have protocol in place that tells us how to
Right.
get that number, or they can give it to us.
Sure.
And then from there, calculate moisture and then calculate the free water. It doesn't make sense when it comes to a Homeric view of what we're supposed to do day to day, and that's what I'm taking it back to.
Right.
The reason why I'm so against this drawing of aggregate, if you've never worked on the same set of mix designs with the same set of materials, like in a ready-mix plant or in a lab that facilitates work for ready-mix plants,
True.
you don't know why you should care about it.
Right.
Drawing out aggregate, it's not just, oh, who cares, John, it's just drawing. So the aggregate's gonna absorb some water. Yes, but we don't know
Sure.
how much it's going to absorb, how quickly, how slowly.
Right.
And that might have an impact on the paste content and how the aggregate moves, or how the paste to aggregate ratio moves.
Sure.
And ultimately what that's going to do is cause inconsistencies, especially when we're talking about human error. So instead of forcing
Sure.
us in what Whitney was saying, in a level playing field, just give us the materials
Sure.
and let us do our dang jobs. Right?
Right.
That, and I'm not saying that to you.
No, I get it though.
Right.
You're right. Like, give me the rock, the sand, the cement you want me to use. Tell me the water is cementitious, and then let me submit the results.
That being said, I recognize our place. Our place is to consider what the rules and regulations stipulated by CCRL. They say, hey, you got to play the game.
Right.
Yeah, we are changing the playing field up. Where else are you going to go, man?
Right.
So we recognize that. And we want you to recognize that. Now, altruistically bless them for creating a program. Hey, nobody ever asked me to create a program for that. You know, we stick to NRMCA programs, but we have never had to be, you know, what they are, that entity.
Right.
So we're saying this.
The protocols, the procedures, right, all the rules.
Right, so whoever owns it, Jim, Joe, Bob, Mary Ann, Sue, Ellen, you know, whoever you are, good job.
Sure.
No, seriously, you could do better, right? And that's what I think that we're doing. We're making this video for two reasons. One, to help out our folk, right? Especially, you know, we've got a buddy of ours who just started in engineering, for bless him.
Right.
And he's,
Are they going to get their CCRL?
Oh, heck yeah.
Okay.
And he's so nervous. You know what we did
are they getting ready to
yeah,
do
they're
their
getting ready.
inspection?
He's terrified.
Yeah, I get it.
And I remember when we first started, we hired one of my buddies from Lafarge. This is
Right.
and he had done CCRL and had him come in to be one, teach us what we're doing wrong, help us. The second day was make sure we're doing right, and then the third time he came in was as an inspector.
Sure.
And, you know, that's what I hope these videos serve as, that benefit to folks who are either going through the CCRL or about to start it. And for Jim, Joe, Bob, Sue Ellen, Mary Sue, you know, maybe this will help you look at what you're doing, the folks that you're hiring. So Patchouli just chopped a whole large portion that you don't get to see until part 3.
Sure.
But let's get back to part 2, the aggregate prep. Why all of this was important is that the aggregate prep, the answers, the slump, the air, the unit weight, all that shtick is going to be based on the materials as well as they conform to the specification that CCRL gives you. So the unfortunate reality is, if you're a person like me that likes to stick to the spec for the aggregate,
you gotta follow the rules.
You gotta follow the CCRL inspection rules, certification rules, material certification.
The instructions.
Ding, ding.
Proficiency sample instructions.
So yeah, I'm excited for you to hear everything we just chopped out. Yeah, that was a good, 2 or 3 minutes?
Oh, longer, I'm sure.
Wow. That's a treasure right there.
That is.
All right, thanks for joining us today.
Like, subscribe, ding that bell for notifications.
Go Concrete!
Beat asphalt.